Hello, my name is Yash Ahuja. In this video, my friends and I will be talking about our class project, which is based on applying the topics of data visualization, analysis, and modeling to predict the trips of the yellow taxis in New York City. Let me start off by giving you a brief introduction on this dataset. It was obtained from the public website by NYC Open Data, from which we have used the yellow taxi trip data of the year 2015. It includes the pickup and drop off times, dates, locations, trip distances, itemized fares, rate types, payment types, driver reported passenger counts, etc. So, the motivation behind this project, on my visit to NYC, we had a lot to see in very little time and on a tight budget. Hence, we traveled on a subway. Doing this project helps to determine if the extra cost of the taxis save us any time in the busy city of New York or not. Before moving on to the visualization part, getting the API key is necessary to import the API. First, you register on NYC Open Data and then you create an application. After that, the code will be displayed. Detailed instructions to this can be found in the README. Now getting to the data visualization. This is the process flow that we followed for the data visualization part. We start off by installing and importing packages like pandas, seaborn, haversine, hollow views, etc. Then we filter the data to remove the outliers, and then we analyze the plots. The first visual aid consists of two maps, the left one showing the pickup locations and the right one showing the drop off. We can conclude from these maps that the yellow taxis run in and around Manhattan only. This map can be also called the taxi density map, where the yellow part of it shows the heavier taxi activity, and the purple shows that the taxi activity is dim, and the black has no taxis at all. This next map is an interactive hover plot for visualizing the traffic density, where the red area shows the high density of traffic activity. So let me show you this. So when we hover around the red area, we can see on the right that the density is really high on the right of the map. And when we move towards the black area, we can see that the density is pretty low. Okay guys, now we're going to move on to the part 2, the prediction model for the trip durations. This is our process flow. Firstly, we install some of our libraries, pandas, numpy, sodapy from where we get our data, matplotlib to plot graphs, sklearn for our regression models. Then we filter data and get out the outliers if any are existing. The outliers we remove are if the passenger count is 0, which is not possible, and if it has a very high passenger count, it is not possible for it to fit in a taxi. We remove those. Then we remove latitude and longitude to fit our model for New York City. Then we fit our test data using regression models. We've used 3, which you will see. Then we analyze some of the performance metrics of these regression models and choose a best model. Then we predict the trip duration using a random forest regressor, and then we analyze this model. These are the performance metrics of regressors we've used. We've used the R-square value, the mean absolute error, mean square error, and root mean squared error. We can see that the random forest regression method has the best values for R-square, since it should have a high value. It should have a low value for mean absolute error, which you can see is the lowest in that method. The mean square error is 107,000, which is also low compared to the other linear regression in the decision tree, and the root mean square error subsequently is also lower. From this choice, we have picked the random forest method. Here are our graphs for the random forest regressor. We did an analysis of predicted results using 10,000 data points. We have chosen 10,000 data points because we wanted some clarity in our graph. On the left, we have a graph of our test data. In the middle, we have a prediction data. And on the right, we have errors in our prediction, that is the test data minus our prediction. We can see that the average data of the test data and prediction is between 0 to 2000 seconds, which is the normally amount of time taken for a taxi trip. On the right, we can see that our errors are quite low and near zero, which indicates our model is valid and good for prediction. Here we have an analysis of our predicted results. On the left, we have a feature versus importance graph. This gives us the important features which have a high impact on our prediction. Initially, the longitude and the latitude are the most important. That is, our location gives the highest impact on our prediction duration. Second, we have pickup hour. That is the time of day, which is very important because in morning we may see medium traffic and in the afternoon we have a high intensity of traffic. On the right, we have a curve for duration versus index. The blue line is for the prediction data and the orange line is for the test data. We see a high overlap of these two lines, indicating that our model is valid and good for prediction.
Hello guys, so part 3 deals with the prediction model to find the best location to pick up customers for each day of the week. The process flow for this model starts from installation of the required libraries. Then data filtering, that is, selecting columns of our interest and removing outliers from the data. Then we define a function to find the best fit of the test data points using linear regression. The next step is grouping the latitude and longitude using k-means clustering. We then predict the best pickup location. And the last step is analysis of the model. The following table is a sample result of the analysis. We can observe that the R-square value is 14.35%. This table also shows the best pickup location for Monday, that is, latitude and longitude values. It also gives the address for this latitude and longitude values. We have used GeoPy library to convert latitude and longitude of a location into address. The following plot shows the k-means clustering of a taxi trip data. From this plot, we can observe that if we neglect the outliers, a taxi trip starting in a cluster will end in the same cluster. The next plot shows best predicted and actual pickup location. The red dot shows the best predicted location and the yellow dot shows the actual location. We observe that the best pickup location for weekdays is centered in and around Manhattan, whereas on weekends the best pickup location is centered around New Jersey. To run the code, first launch your Jupyter notebook and go to the location where notebook is located and open it. Use your API token and account credentials to import data. Then run each block of the code and wait till each block is processed. For future scope of a project, comparative analysis can be done for green and yellow taxis and their respective efficiencies can be evaluated. Also, weather data can be combined with taxi data to explore the influence of weather on traffic behavior in New York. This slide shows all the references for our code. Thank you.